So good afternoon everyone. So today we will again see numerical differentiation. So we have studied till now numerical differentiation using Newton's forward and backward differentiation, and numerical differentiation using Stirling's and Bessel's equations. Okay, so all these methods are used for equal spaced values of x or equal intervals. Okay, so today we will see numerical differentiation with unequal intervals or unspaced values of x. Okay, so first we take problem. Okay. Given that this is a very important question asked many times. So x 1.1, 1.2, 1.3, 1.4, 1.5 and 1.6. Okay, and y is 7.8, 7.989, 8.403, 8.781, 9.129, 9.451, 9.750, and 10.03. Okay, so table is given and we have to find dy by dx and second order derivative at A, x is equal to 1.1 and B, x is equal to 1.6. Okay. So you have to find the first derivative and second derivative at x is equal to 0.1 and x is equal to 1.6. So this table is given, value of x is given and value of y is given. Now tell me which formula we will use here to find the value of dA by dx and d square y by del x dx square at x is equal to 1.1. Okay. So which formula you will use to find this? Anyone? And then we have to find also value of dA by dx and second derivative at x is equal to 1.6. Okay. So, and suppose we have to find the value of dA by dx at x is equal to 1.3. So, when x is equal to 1.1, which formula you will use? When x is equal to 1.6, which formula you will use? And when x is equal to 1.3, which formula you will use? Okay, anyone? So this is a summary of what we have done in last two classes. Okay. Then we Stirling formula, which will be applicable for which value of x? X is equal to 1.1, x is equal to 1.6, or x is equal to 1.3. So Tushar had said forward interpolation. Okay, x is equal to 1.1. Okay, very good. Anyone else? So you have to know which formula has to be applied for certain values of x. Okay. So here x is equal to 1.1. It is in the beginning of the table. Okay. X is equal to 1.6. It is at the end of the table, and x is equal to 1.3 is in the middle of the table. Okay. So all values of x in the beginning of the table, in the middle of the table, and in the end of table is given. Okay. So you should know which formula we have to apply. Okay. So Tushar said at x is equal to 1.6 backward interpolation. Okay. So for this we will use Newton's forward difference interpolation. Okay. Because here we have to find the value at the beginning of the table. Okay. And here we will use Newton's backward interpolation. Okay, and for this it is the middle of the table, so we will use Stirling's or Basel's. Okay, so you should know which formula will be used for the different values of x. Okay. So it is clear where to use which formula. Okay. So in the beginning of the table, we use Newton's forward interpolation or difference formula. At the end of table, Newton's backward interpolation formula, and in the middle we use Stirling's or Basel's formula. And it is applicable for evenly spaced value of x. Okay, when equal interval is given. Okay, can we? So this is applicable. These formulas are applicable for evenly spaced value of x. Okay, so here value of h is same. It is 0.1. Okay, so that means whenever you have to find the value of differentiation dv by dx and higher order at the beginning of the table. Okay, so we use dv by dx at point x naught, okay, at any value. So this will be 1 upon h del by del number minus half del square y naught plus 1 by 3 del cube y naught minus 1 by 4 del square of 4 y naught plus 1 by 5 del to the power 5 y naught minus 1 upon 6 del to the power 6 y naught and so on. Okay, so we have derived this formula. So we have derived this formula from Newton's forward difference interpolation. Okay, so whenever at the beginning of the table we use this formula. Okay, and at the end of the table we go with backward formula 1 upon h. So this will become yn. Okay, so this will become, so for beginning this will be y naught, and for the end of the table this will be yn. Okay, and all are 1 upon 2 del square y naught plus 1 upon 3 del cube y naught plus 1 upon 4 del to the power 4. This will be 1 upon 5 del to the power 5. Okay, so this is for the value of x at the end of the table. Okay, and this is for value of x at top of the table. Okay, so it should be clear. So when we have to find the value of du by dx, let's say at 1.1, 1.1, so you use this formula, and we have derived it from forward interpolation. And when you have to find the value of du by dx at the end of table, that is 1.1 or 1.6, we use this formula which is derived from Newton's backward interpolation. Okay, and if you want to find the value of du by dx at the middle of the table, we generally use Stirling's formula or Bessel's interpolation formula. Okay, so this should be clear to. So now we have to construct this forward difference in order to find the derivatives. Okay, and this is very important question. Normal comes in combination. So many times has come in the result. Okay. So first we prepare this difference table. This is x 1.0, 0.1, 1.2, 1.3, 1.4, first we have to prepare this difference table, and only we can find the derivatives. Okay. First we will find first difference. Okay. So first difference, so 8.403 minus 7.989 is 0.414. Difference of these two is 0.378. Difference of these two is 0.348. Difference of these two is 0.322. Difference of these two is 0.299, and difference of these two. Okay, so first you have to prepare this table. So this is forward difference, then second difference. So these two, difference of these two. So this will be del square. So this is minus 0.036. This is 0.030 minus 0.026 minus 0.023 plus 1.01. Okay. So 0.281 is subtracted from 0.229. Get this. This is subtracted from this. This is subtracted from this, and so on. Okay. So in this way we find the difference table. Then third difference of this values here 0.006. This is 0.004. This is 0.003, and this is 0.005. Then fourth difference. This is 0.0002. This is minus 0.001. This is minus 0.002. This is a fifth difference. Difference of these two. So this will be 0.001, and this is 0.02. Last difference of this two is 0.00. Okay. So this is the difference table. Okay. Then we have to find dv by dx. So we use formula. So we have dv by dx at x is equal to 1.1 is equal to 1 upon h del y naught minus half del y naught square plus 1 by 3 del y1. So let's go minus 1 by 4 del square del cube equal to 4 y naught plus 1 upon 5 del to the power 5 y naught minus 1 upon 6 del to the power 6. Okay, so this is the formula, and we have to find these values So you have to find delta y naught. So where you have to find the value of du by dx at x is equal to 0.1. So this value will be x naught, and corresponding to this will be our y naught. Okay, and corresponding value, so this will be corresponding value of y naught will be this. So this is del y naught. Okay, and the second value will be del square y naught. This will be del cube y naught. Okay, this will be del to the power 4. This is del to the power 5. Okay, these values are okay. So now we substitute these values. So if you have to find the value of du by dx at 1, so this will become y naught, this will be del y naught, del square y naught, del cube y naught, and so on. Okay. So if the question is asked that you have to find the value of du by dx, it is equal to 1.3. Okay. So this at 1.2. So this will become y naught, this delta y naught, del square y naught, del cube y naught, and so on. Okay. So we have to substitute this value. So 1 upon h. Okay. So value of h is 1, 1.1, 1.2, 1.3. So it is clear h will be equal to 1.1 minus 1 is equal to 0.1. Okay, so value of h is 0.1. This will be 0.1 divided by del y naught square. Del y naught. So this is 0.378 minus. So this is minus. So this will become half plus divided by 2 del square y naught. So this is 0.03 plus 1 upon 3 del cube y naught. Del cube y naught is 0.004 minus, this is minus, this will become plus 1 upon 4 del to the power 4 y naught is 0.01 plus 1 upon 5 del to the power 5 y naught is 0.02. Okay. So we have to substitute these values, and you will get du by dx at x is equal to, I'm solving this, 1.1 is 3.95. Okay, so this is the value of du by dx. So we have to remember this formula. Okay, so it is derived from Newton's forward interpolation formula. Okay. Now we have to find the second derivative also. So the formula will change for second derivative. So for second derivative is 1 upon h square del square y naught minus del cube y naught plus 11 by 12 del to the power 4 y naught minus 5 upon 6 del to the power 5 y naught plus 137 by 180 del to the power 6 and so on. Okay. So here what we del square y naught and then del to the power 4 y naught and del to the power 5 y naught, and this is del to the power 6 y. Okay, there is no del to the power 6 y naught. So substitute these values. So h is 0.1 whole square. Del square y naught is minus 0.01 0.03 minus 12 q y naught is 0.004 plus 11 upon 12 10 to the power 4 y naught. So this is minus 0.001 minus 5 upon 6 10 to the power 5 is 1. Okay, so you have to prepare this table and you have to substitute the values of del y, del square, y naught, del q, y naught, del to the power 4 y naught, del to the power y naught in the given formula. Okay, so you will find this second derivative. Okay, and x is equal to 1.1. So on solving this, you will get q square by dx square at x is equal to 1.1 is minus 3.7. Okay. So we had so dy dx at 1.1 is and dx square by dx2 is calculated like this. Okay. X is equal to 1.1. And second question is that second part you have to find the value of dy dx at x is equal to 1.6. Okay. So now our x naught will change. Okay. So now this will shift to the bottom of the table. So this is now this is our x naught. Sorry, xn. So this will become xn, and corresponding to this is yn. Okay. Okay. Then this will be del yn. This is del square yn. This is del cube yn. This is del to the power 4 yn. This is del to the power 5 yn. And this is del to the power 6 yn. Okay, so you have to take the bottom value of the difference. Okay, so when you are calculating the value of dy by dx for the value of x which is at the bottom of the table, so you have to take xn corresponding yn, then delta yn, del square yn, del cube yn, del to the power 4 yn, del to the power 5 yn, and del to the power 6 yn. Okay. So now formula will change accordingly. So at x is equal to 1.6. So at x is equal to 1.6. So dv by dx will be equal to 1 upon h del y naught, so yn half del square yn plus 1 by 3 del cube yn plus 1 by 4 del to the power 4 yn plus 1 upon 5 del to the power 5 yn plus 1 upon 6 del to the power 6 yn. Okay, and so on. So here we have only del to the power 6. We will calculate up to here. Okay, so formula will change accordingly. So by using backward difference operator, okay, so it is that's it. So we have to use backward. So it says backward difference operator. We have to use backward difference operator. Okay. So now substitute these values. Okay. So this is del yn is point. So h is 1 upon 0.1. So del n is 0.218 plus half into del square yn is into minus 0.018 plus 1 upon 3 del cube yn, so this is 0.005 plus 1 upon 4 del to the power 4 is 0.002 plus 1 upon 5 into 0.003 plus 1 upon 6 into 0.00. Okay. So solving this, you will get d by dx at x is equal to 1.2 is 2.75. Okay. Solve this equation, you will get dy by dx at x is equal to 1.6 is 2.75. Okay. Next, we have to find the second derivative also. Formula will change. Will be e square x square 1 upon h square back over by n plus y cube n plus 11 by 2 4y n plus 5 upon 6 del to the power 5 by n plus 137 upon 150 del to 6. Okay, this will be changed accordingly. This is 0.01 whole square. So this will also change. So we have to use backward operator. Backward difference. So this is first, second, third, fourth, fifth, sixth. So now what we have del square yn, so this is minus 0.018 plus del cube is 0.05 plus this value 11 upon 12 into 0.002 plus 5 upon 6 into 0.003 plus 157 upon 150. Okay. So in this way, we have to solve. This is with the help of backward and forward formula. So this is coming to L square by x square x is equal to 1.6 is 2.7. So this is the value of d by dx, the second derivative at x is equal to 1 and x is equal to 1.6. Okay. So when you have to find the value of d by dx derivatives, at the top of the table we use Newton's forward interpolation. integration formula. Okay, and we use these difference values. Okay, and when you want to find the value of du by dx at the bottom of the table, so we go with these differences. Okay, the differences at the bottom of the table. Okay, so you have to choose the formula accordingly. Okay, and if you want to find value of du by dx at the center of the table or middle of the table, so we use Stirling's and Bessel's formula. Okay, so which we have covered in last class. Okay, so any doubt in this part? So this is for equispaced value of x. Okay. So now we will see the derivatives using unequal space value of polynomials. Okay. Last topic is numerical derivatives. Then we will start the clarification in next class. So using unequal space values So we have derived the values of derivatives, the formula of derivatives with equal spaced values. Okay, values of arguments. Okay, what is the argument? Is x, value of x. Okay, so we have derived different formula for du by dx and higher order du by dx square for equally spaced. Okay, so in the last question we have seen that using Newton's forward and backward interpolation formula. Okay, so we generally use when equally spaced value of argument is given. So we use Newton's forward and backward interpolation formula. So forward is for the value of argument at the top of the table, and backward is used at the bottom of the table. So the values of x or arguments. When the value of argument is given at the bottom of the table, we use backward interpolation, and when value of arguments are given at the top of the table, we use Newton's forward interpolation formula, differentiation using. Okay, and for the middle of the table, we use Stirling's or Bessel's interpolation formula. Okay, and all these formula are applicable only when there is equally spaced value of arguments. Okay, so what do you mean by equally spaced value of arguments? Like x is given 1, 2, 3, 4, 5, 6. So these are equally spaced value of arguments. Okay, like 1.1, 1.2, 1.3, 1.4, 1.5, and 1.6. So it should be clear. So when the equal space value of arguments is given and you have to find the derivatives, so use Newton's forward and backward interpolation for the value of argument at the top of the table and bottom of the table, and for middle of the table Stirling's and Bessel interpolation formula is used. Okay, so now we are dealing with unequal space value of arguments. Okay, so anyone can tell which formula we will use here for unequal values of interpolation, unequal values of arguments. So we have covered it in other classes for when we are studying interpolation. Okay, with unequal spaced values. So which two methods will be used here to find the derivatives? Okay, anyone? Interpolation formula used for unequal spaced values of argument. So anyone? Lagrange's, very good. And second one, there are two formulas, interpolation formulas for unequal interval. Very good, Tushar. So first one is using Lagrange's interpolation formula. Second one, anyone? Newton's. What next? So next is Newton's divided difference. So these two formula are used when there is unequal spaced values of argument are given, okay, or unequal interval of arguments are given. Okay, so we use generally these two formula. Okay, so we will derive value of d by dx using this Lagrange's and interpolation formula. So first we will see Newton's divided formula, okay, and then we will go to Lagrange's. So Newton divided formula is f of x is equal to f of x naught plus x minus x naught del f of x naught plus x minus x naught x minus x1 then square f of x naught plus x minus x naught x minus x1 x minus x2 del f of x naught. Okay, so this is Newton's divided formula. Okay, so what we find, what we need to find is f dash x, okay, which is equal to, let's suppose f of x is equal to y. So with respect to x, differentiating it, so this will be dv by dx. Okay, so this is Newton divided difference formula. So differentiating above equation with respect to x. So this will give f dash x. This will be f dash x naught. Okay. So this is constant term. This will be 0. I'm writing. So this is del of x0. This is 1 and this will 0, so it will get del of f0. Okay. Then 2x minus x plus x naught x1 del square f x naught. Okay. So if you multiply this, so this will become x square. Differentiation of x square will be 2x. Okay. And then if you differentiate this, so x plus x naught will taken common into x. So differentiation of x will be 1, and this is x naught. So this is x square minus x naught plus x1 into x plus x naught into x1. Okay. So differentiation of this is 2x. Differentiation of this will be 1. So you get this, and these are constant terms. So this will be 0. Okay. So similarly, you can find the further values. This is 3x cube. Here you will get x cube. So this will be x square minus 2x x naught plus x1 x2 plus x naught x1 x1 x2 plus x2 x3 del cube of x. So this is the this much using Newton's divided difference. Okay. In similar way, you can find the value of d by dx using Lagrange's difference formula by differentiating it with respect to x on the both the side. Okay. So this is the formula which will be used for finding the value of derivative del f dash x. Okay. So we will solve one problem based on this. Okay. So find f dash at x is equal to 10 from the given table. Okay. So you have to remember in this formula. Okay. If you not want to remember this formula, just remember the formula of Newton's divided difference and then differentiate it with respect to it. So you will get the formula. Okay. So table is given. Value of x is 3, 5, 11, 27 and 34. Okay, so you can see from the values of the argument, it is clear this is unequally spaced. Okay, and f of x is minus 13, 23, 89, 899, 17315 and 35606. Okay. So again, we have to prepare these difference tables. Okay. So first difference, first divided difference. Okay. So this is 23 plus 30 This is y1 plus y1 minus y naught divided by y minus 3. So this is divided difference. 89.23 divided by 7 minus 5 and 7. I hope you remember this. 27 minus 11. 35. These are the corresponding values. So you can find the difference table. Newton's divided difference. Okay. This is equal to 146. This is equal to 1025, and this is equal to 46. Yes. Then second divided difference. Will be 146 minus 3 divided by 11 minus 3. Then 125 minus 146 divided by 27 minus 5. 4613 minus 1025 divided by 24 minus 7. This is equal to 16. This is equal to 39.96. Then third difference. So I am writing that the values 0.998 and 1.0. Last. This is very small. 4 divided. So we have to prepare this divided difference like this. Okay. So now we have to apply the formula. So Newton's divided difference formula for first derivative. Formula for first derivative is f dash x is equal to f of x naught x1 plus 2x minus x naught minus x1 f of x naught x1 x2 plus x square minus 2 x naught plus x1 plus x2 plus x naught x1 plus x1 x2 plus x2 x naught multiply f of x naught x1 x2 and last term is this is very lengthy formula. So in the examination it will ask about third term only. Okay. X naught x1 x2 plus 3 plus 2 into x x naught x1 plus x1 x2 plus x2 x3 plus x3 x naught plus x1 x3 plus x naught x2. Last one is minus x naught x1 x2 plus x1 x2 x3 plus x2 x3 x4 0 plus x naught x1 and multiplied by x naught x1 2 this is the formula. It is very lengthy formula. So this is x naught, this is x1, x2, x3 and x4. Okay. Substitute these values. So you will get f dash of 10 is equal to 232.86. So you will get this one. Okay. So this is formula of derivative for unequal not equispaced values of arguments using Newton's divided difference formula. Okay, so this type question is really you are because this is very lengthy. So this will ask up to this only, up to x3. Okay. So any doubt in today's class? शायद पूरा तो याद नहीं, यहाँ तक बस याद रखो, ठीक है। ये तीसरे टर्म तक, बस एग्जाम में आएगा तो वही आएगा, इतना नहीं आएगा होगा। ठीक है, मैंने बता दिया कि कैसे सॉल्व करते हैं, बस आपको इतना ही पूछेगा। ठीक है, मतलब ये यहाँ तक एग्जाम में नॉर्मल नहीं है। ठीक है, और कोई? Okay then. Thank you, class.